Okay, so for ionic compounds, we are working with metals now and nonmetals, or metals with polyatomic ions, which are made up of a bunch of nonmetals generally, okay? Now, ionic compounds involve charge. So because they involve charge, pluses and minuses, we don't use any prefixes. So you will never see, or you will very rarely see, you don't see mono, di, tri, tetra anywhere. The way that they're formed is by balancing the charge, okay? And by balancing the charge, you're gonna make it add up to 0. And again, we'll just practice, okay? So the first one I'm gonna do is probably the most common ionic compound you've seen. All right, so we have this. I'm going to clear this now. And it's this guy. Okay, this is salt, right? But it has a name. And you actually know how to name it already because you've probably heard of it before. What's its name?
Sodium.
Sodium chloride, right? So you name the first element. And then you name the second element and replace it with IDE. Now, the difference is we don't call this sodium monochloride. And how do I know? Well, it is going to be your responsibility to recognize the difference between ionic and covalent compounds. So how do I know this is ionic? Well, this is a metal, this is a nonmetal. Metal, nonmetal. Metal, nonmetal. Ionic. These are nonmetals only. So no prefixes. Okay, so the question is why does it go together like this? Well, if you look at the periodic table, sodium is +1, chlorine is -1. +1 and -1 add up to 0. So that's why you have one of each. Questions? All right, let's keep going. Oops. We're going to do some easy ones to start. KF, who's K? Potassium. Who's F? Fluorine, right? Fluoride. Now, be careful. Li2O. Oh, I'm sorry, let's go back to the KF. So find potassium on your periodic table. It's in this family, so +1. Where's fluorine? -1. +1 and -1 add up to 0. Okay, Li2O. Do I call this dilithium? I do not. Why? This is a metal. Oxygen is a non-metal. So I don't use prefixes ever. So I just name it lithium. And then this is oxygen, so oxide. No prefixes for ionic. So hopefully you can see how this can get confusing, is remembering when to use prefixes and when to not. And that is completely based on whether the compound is ionic or covalent. So you need to know what it means to be ionic and you need to know what it means to be covalent. So lithium oxide. And the question is, well, why is there a 2 here? So let's talk about that. So this is where ionic compounds can get difficult or more complicated. So let's find lithium on the periodic table and let's find oxygen. So lithium is in my alkali metal family. So its common ion is +1. Go back and find oxygen. The oxygen is right here. What's its common ion? -2. So I need to get these to balance out. So lithium and oxygen have to add up to 0. And right now, they don't. +1 and -2 doesn't add up to 0. So if this is -2, in order to cancel it out, I need this to be +2. And it's not. I can't just change the charge of it. So what I do is I add an extra one. If I have 2 lithiums, it would be like this. +1 and +1 adds up to +2, right? And then that will help cancel out the -2. So when I write its formula, I call it Li. I have 2 of them. O, lithium oxide. Okay, so let's try a different one. So magnesium is a metal. Sulfur is a non-metal. So this is magnesium sulfide, IDE. Okay, why do they go together like this? Well, let's reference back to the periodic table. Magnesium is right here, +2. Sulfur is right here, -2. So let's look at that. Magnesium +2, sulfur -2. +2 and -2 cancel out, so you just have an Mg and you have an S. Magnesium sulfide. So questions on naming so far for ionic compounds and writing formulas. We're going to do a couple of more practice, and then we're going to move to adding the polyatomic ions, and then I will end class. So let's see. Okay. Calcium is a metal. Nitrogen is a non-metal. Therefore, this is ionic. When it's ionic, you don't use prefixes. So I just name it calcium. Calcium. Who's nitrogen? Nitride. Okay. No tri, no di, no anything, because it's ionic. Calcium nitride. Now, let's talk about why there is a 3 and a 2 here. So what is the common ion for calcium? Oh, wait. So it's 2. Please don't say 2, though. It's +2. Okay. What is the common ion for nitrogen? So go to your periodic table. -3. Good job. Okay. So just like in math, like these are charges, right? Like if you were trying to find a common denominator between a 2 and a 3, you would say 6, right? So we're going to find a common charge, right, instead of a common denominator, and it's going to be 6. So how do I get this to be +6? Well, I'll need 3 of them. 3 times 2 is +6. How do I get this to be 6? Well, I need 2 of them. Well, 2 times 3 is -6, right? So calcium, I have 3 of, it goes as a subscript, and nitrogen, I have 2 of, and that is why it looks like this, is because you needed that to balance the charge. Okay, I'm going to work with polyatomic ions next, and then we will be finished for the week. So this stuff is not on your test on Monday. All right. So a common polyatomic ion that you needed to memorize was this guy. You need to memorize these. So make flashcards, do whatever it takes. You need to memorize them. This guy's name is nitrate. Okay, it's NO3 -1. It's called poly because it has more than one element, a polyatomic, and then ion because it has a charge, -1. Nitrate, non-metal, non-metal. Most of your polyatomics are a bunch of nonmetals thrown together. So if I do this, it's going to be your job to recognize this as sodium, and then you need to recognize this polyatomic ion. It's nitrate, so its name is sodium nitrate. That's how you name it, okay? And you go, well, why is it thrown together like that? Well, sodium is +1 and nitrate is -1. So they cancel out perfectly. Sodium nitrate. So metal, polyatomic. That is also ionic. Metal, polyatomic. The polyatomics I sent to you. It's also going to be on the reference sheets on our main home page under reference sheets, but I just sent it to you on Canvas. It looks like, oh shoot, I don't have it pulled up. Give me 1 second. You know what? It's in here. It looks like this, and all the ones you need to memorize are highlighted. Okay? So, let's try something else. This polyatomic ion's name is carbonate. So again, you need to memorize that. So look at this. I'm going to pair it with sodium again. It looks like this. So this guy's name is sodium, metal, carbonate, polyatomic. Sodium, carbonate. So you go, well, why do they go together like this? Well, sodium is +1. Carbonate is -2. So how do I get these to match? Well, if this is -2, I need this to be +2. And I can't just change the charge of it. So instead of changing the charge of it, I'm just going to say I have 2 of them, because 2 of them would be a total of +2 and -2. So it's Na2, I have 2 of them, carbonate. Sodium carbonate. So ionic formula writing and naming is much more complicated and requires a lot more effort than covalent or molecular formula writing and naming. You have to pay attention to charges. You have to make the charges add up to 0. And again, usually the hint is that first element, right? That generally in ionic compounds, if it's ionic, the first element is the metal. Almost always are the metals written first. Almost always. Okay. Again, these involve cations, positively charged ions, and negative anions, right? And we balance them out to add up to 0. That's what your job is, to force them to add up to 0. And again, we never, ever, ever use mono, di, tri, tetra, penta, anything like that for ionic compounds. So I'd never call this like disodium carbonate, okay? It's not going to be di anything, and it's not going to be disodium carbon trioxide. That's not how it works. This is a metal, sodium. This is a polyatomic ion that you will get used to recognizing, carbonate, so sodium carbonate. Okay, so I'm going to put up a worksheet in a little bit for you guys to be able to practice ionic naming and formula writing for the weekend. And then again, you'll study for your test. I didn't get a chance to answer questions. Hold on, let me pause this.